Hi, everyone, and welcome back to our lecture. We left off class the other day talking about and introducing titrations, and now we're going to apply that conceptual knowledge to figure out how we can do some calculations and quantifications to calculate an unknown concentration or an unknown volume that we need for a titration. So, as a little bit of a review, where we left off last time, we defined our equivalence point as saying our moles of acid in our solution equals our moles of base. So that means our moles of H plus equals our moles of OH minus, because as a reminder, titration, I am either adding a certain amount of acid to base, or I'm adding a certain amount of base to acid. And utilizing our unit 3 knowledge, we can recall that if I know my concentration in molarity, and I know my volume of solution added, or my V, I know my molarity is equal to my moles divided by volume, specifically my moles divided by liters. So I'm able to say that my moles N is going to be equal to my molarity times my volume, which means if I know my moles of acid equal my moles of base, that means my moles of acid, or my N of acid, is equal to my moles of base, or N of base. So if I know my N of acid equals my N of base, I can plug in, because I know N is equal to MV. When I plug in, we end up getting that the molarity of our acid times the volume of our acid is equal to the molarity of our base times our volume of base. So our M1V1 equals M2V2 calculations not only work for dilutions, they also work for calculations for our titrations. However, really important piece of info here. Sometimes when I mix acids and bases, my acids can be something called diprotic or triprotic. Diprotic means we have 2 protons. Triprotic means we have 3 protons. Sometimes our bases even can have more than one hydroxide group. Before I even start a titration problem, we always have to identify the ratio of H plus to OH minus based off of the identity of our acids and our bases. If we have H2SO4 mixing with a base, if I have a ratio of H plus or OH minus being 2 to 1, that means I have 2 H pluses for every 1 OH minus. If we have 2 moles of H plus for every 1 mole of OH minus, then I need to multiply 2 times my molarity of acid times my volume of acid, and we set that equal to 1 times my molarity of base times my volume of base. Again, the reason we would need to do that is if I have an acid that has more than 1 H, meaning it has 2 or 3 or even 4 H's. An example of that is sulfuric acid, H2SO4, means that 2 moles of H2S or 2 moles of H plus are produced. And if I have a base like BaOH2 or barium hydroxide, we have 2 OH minuses produced. So I need to be able to qualitatively evaluate my ratio of H plus to OH minus before getting started. So doing a little bit of a recall from what we just talked about and applying that into our practice problems. Here, we're told that the end point of our titration, our end point, as a reminder, is equal to our equivalence point when we talk about titrations. The end point of a titration, a 50 milliliter sample of aqueous HCl, was reached by adding 35.23 milliliters of 0.250 molar NaOH titrant. And it's asking, what is the molarity of HCl? We're given our acid-base reaction here. We have HCl reacting with NaOH to form NaCl and H2O. As a reminder, in an acid-base reaction, when I have my acid and I add a base, that will always yield a salt plus water. A salt, as a reminder, is a fancy way of naming an ionic compound. And I know that we haven't actually done these in lab yet, but even in practice problems, seeing how we set up our experiment can sometimes help us understand what math we have to do. So thinking about how we would set this up, and we're going to get practice with this in our next class, In our burette, right, I put some sort of amount of a known solution in our burette, and I add that to my flask with an unknown concentration or an unknown amount. So here, we know in the context of our problem, I add 35.23 milliliters of 0.25 molar NaOH. I add that volume from our burette into our flask. And inside our flask, we start off with 50 milliliters. So I measure out 50 milliliters of a blank or unknown concentration of HCl. So I've given you an unknown concentration of HCl. You measured out 50 milliliters of that and put that into our flask. When I add this amount, 25.23 milliliters of our 0.250 molar NaOH, when I add that into our flask, we reach our endpoint, which again is moles base equals moles of acid. So let's go ahead and start to actually quantify our problem. But let's see that in action first. So we showed this video at the end of our last class, and I wanted to give a little bit of another visual clue to help us understand what's going on in the context of a practice problem. So when we take a peek and I play this video, inside our beaker right now, we have 50 milliliters of an unknown concentration of HCl. We have 50 milliliters in here. Inside our burette, which we see the bottom of right here, we're slowly dropping in 0.250 molars of NaOH. So as we notice, as I'm putting drop by drop amount of NaOH in, we start to see that our solution is slowly turning pink. The pink is indicating that we're getting closer and closer to our endpoint. As we're stirring this, there's a stir bar in here. As we're stirring it, the pink appears and then it disappears. If our pink disappears, that indicates that we haven't reached our endpoint quite yet. But if we keep adding, we notice at a certain point, we've added enough NaOH into our beaker to now reach our endpoint, aka our equivalence point. So at this point in our actual reaction, our solution will turn pink and stay pink when we've added 25.23 milliliters of NaOH into our 50 milliliters of our unknown HCl, because we have now reached our endpoint. So that's actually what we visually are seeing when we do a titration, and that's what we're going to be doing when we're in lab next class. So let's start solving some problems. Again, we have our same problem here. The first thing that I need to do is evaluate what type of acid do I have and what type of base do I have. I have HCl, and we notice there's only one H in HCl, so I have 1 mole of H plus produced. And in NaOH, I only have 1 OH, so I have 1 mole of H plus for 1 mole of OH minus. We get that because 1 H plus comes from HCl, and 1 OH minus comes from NaOH. Now that I've decided that my ratio of H plus to OH minus is 1 to 1, we proceed with our normal setup. I know that my moles of HCl have to equal my moles of NaOH at my endpoint or my equivalence point. So I plug in my molarity of HCl times my volume of HCl is equal to my molarity of NaOH times my volume of NaOH, and I'm interested in the molarity of HCl. So I plug in everything else, and when I solve, my molarity of HCl is equal to 0.176 molar. That means I have now solved for the concentration of my unknown because I know specifically at the endpoint, aka equivalence point, I know my ratio of how much H plus I have for how many moles of OH minus I have. Next, our last practice problem, we're asked what volume of 0.0105 molar hydrobromic acid, or HBr, solution is needed to titrate 125 milliliters of 0.0100 molar calcium hydroxide solution. Here we have our base. We're adding that to our acid, and it yields salt plus a water. And our setup will look like this. Inside our burette, we're going to have to figure out how many milliliters of this concentration of HBr I add from my burette into my flask. As a reminder, I know I put HBr into my burette because I know my concentration. I then add 125 milliliters of 0.01 molar CaOH2 into my flask. And that's how we're going to do our titration. I need to figure out how many milliliters I deposit utilizing my burette into my flask. So the first thing we have to do is evaluate my ratio of OH minus to H plus. We notice CaOH2. I have 2 hydroxides for every 1 H plus. OH2 indicates 2, and I only have 1 H plus right here. So for every 1 mole of H plus, I have 2 moles of OH2. Now, what I do is I plug in. We know that for every 1 mole of HCl, that has to be equivalent to 2 moles of OH minus. So I now have this factor of 2, and I carry that through and multiply 2 into my molarity of NaOH times my volume of NaOH. And I set that equal to my molarity of HCl times my volume of HCl. Now that we've done the hardest part, we just plug in what we know. I know my concentration of HCl. I'm solving for my volume of HCl, and I have to multiply 2 into my molarity of NaOH times my volume of NaOH. And when I solve, that gets me that I have to add 238 milliliters of HCl into my NaOH in order to reach my equivalence point. And that is the end of our mini lecture, and you're going to be able to complete our pre-lab questions. So make sure to bring those for our next class and submit them to Google Classroom, and I will see you then. Bye, everyone.